exercise 3 is potentially a real-life situation. Say you're working at a chemical company and your company is trying to make money off of selling hydrogen iodide gas. Well, your boss asks you, can we make hydrogen iodide gas, and what would we need to do to make it? And so you look up the equilibrium constants for this reaction, 1 mole of hydrogen gas reacting with iodine gas to produce 2 moles of hydrogen iodide gas, and you find that it has different values for the equilibrium constant. At room temperature, 298 Kelvin, you see that the equilibrium constant is 794. But if you raise the temperature to 700 Kelvin, the equilibrium constant goes down, decreases to a value of 54. So, should you tell your boss that you need to carry out the reaction at a higher temperature to make more hydrogen iodide gas? Or do you need to have the reaction take place at about room temperature, or even perhaps a cooler temperature to get more hydrogen iodide gas? Which temperature is the more favorable temperature to produce hydrogen iodide? So what did we just say about the value of K? Remember that we said as K is larger, products are favored. So if you're trying to make money by selling hydrogen iodide gas, you want products to be favored because hydrogen iodide is your product in this case. So which temperature has the larger value of K? We see that K is larger at lower temperatures. At 298 Kelvin, our equilibrium constant was 794. At 700 Kelvin, our equilibrium constant is 54. So if we keep the reaction a nice, comfortable room temperature, we're actually going to get more product produced that way, which is good news for your employer because employers don't like to do things at higher temperature because it costs money to raise the temperature for reactions. So the answer for this question is that the formation of hydrogen iodide is favored at lower temperature. Now, in this exercise and in the previous ones, we've been able to calculate the equilibrium constant using equilibrium concentrations that were given to us. But in future problems, all equilibrium concentrations are not going to be given to you at the start of the problem. So in the next video, you'll find out how to calculate equilibrium constants when you're not given all of the equilibrium concentrations.